By every rule we have, 3i Atlas should already be forgotten. That's how interstellar visitors are supposed to behave. They arrive, they surprise us, they disrupt a few theories, then they fade quietly back into the dark where they came from. End of story. Except, that's not what happened this time. Because while headlines moved on, while timelines filled with newer distractions, something strange was happening behind the scenes. Astronomers didn't move on. Telescope schedules didn't clear. Observation requests didn't stop. They doubled down. Right now, this week, some of the world's most powerful telescopes are still tracking 3i Atlas, a shrinking, fading dot already leaving the inner solar system, a target so dim it barely justifies the effort. And yet, scientists keep pointing their instruments at it. That's not nostalgia, that's fear of missing something important. Here's the uncomfortable truth. 3i Atlas is not behaving like an object whose story is over. On paper, the script was simple. An interstellar object enters the solar system. Solar heating activates it. Brightness rises. It reaches closest approach to the sun. Then activity collapses. The coma fades. The tail thins. The light curve slides down smoothly, predictably, boringly. That's how comets end. But when astronomers plotted the most recent brightness data from 3i Atlas across multiple nights, observatories, and instruments, something felt wrong. The curve didn't crash. It hesitated. The data points sat just above where they should be. Not dramatically, not explosively. Just enough to be irritating. Just enough to refuse closure. Night after night. Same result, no final flare. No cinematic outburst. Just a quiet, persistent refusal to fade on schedule. At this distance from the sun, the coma should be collapsing into a ghostly smear of old dust. Instead, the inner region remains oddly sharp, structured, alive. When researchers stacked images, they found small but repeatable bumps in the light curve, tiny deviations that shouldn't exist anymore. And this timing matters. Right now, 3i Atlas is at a decision point. Within days, maybe weeks, the brightness curve must choose. Either it finally drops and confirms it's shutting down, or it continues stalling, proving something inside is still feeding energy into the system. That's why scientists are still watching this week, not last year, not next month. They're trying to catch the moment when 3i Atlas reveals what it actually is. Is it just a comet running late, or an object powered from deeper layers than our models allow? Because if it's the second option, this isn't just another interstellar comet. It's a warning shot. And brightness was only the first thing that refused to behave. Because when scientists looked closer, they realized something else was changing too. Something far more dangerous. At first, the pulsing light didn't seem alarming. Comets flicker all the time. Uneven surfaces. Rotations. Active patches turning in and out of sunlight. That's normal. But 3i Atlas didn't flicker like a normal object. Its light curve had layers. A main rise and fall, yes, but on top of that, smaller pulses appeared, repeating, structured, persistent. This wasn't random noise. When astronomers tried to model it, the simplest explanation didn't work. A single rotating body should produce one clean cycle, bright side, dark side, repeat. Instead, 3i Atlas behaved like it had multiple active engines. One region would flare. Brightness spiked. Then it rotated away, and another region ignited. Then another. The light curve showed multiple peaks per rotation. That alone was strange. Then came the part that made people sit up straight. When scientists tried to lock down the rotation period, the peaks refused to line up. Each night, the pulses arrived slightly earlier than predicted. So the assumed rotation period had to be shortened, then shortened again. And again. The conclusion was unavoidable. 3i Atlas was spinning up. Jets weren't just venting gas. They were applying torque. Tiny thrusters firing unevenly, slowly accelerating the object's rotation. For a solid asteroid, that might be manageable. For a fragile, porous comet-like body, That's a structural nightmare. Spin it too fast, and centrifugal forces begin tearing it apart from the inside. Cracks propagate. Stress builds. Material sheds. In extreme cases, fragmentation. Now the question changed completely. This wasn't just what is 3I Atlas. It became, will 3I Atlas survive itself? That's why astronomers are still burning entire nights watching a fading dot. They're tracking rotation hour by hour, folding light curves across multiple nights, coordinating observatories across time zones, all to answer one brutal question: has the spin finally stabilized, or is it still accelerating? If this week's data lines up cleanly with last week's period, it suggests the torque is easing. Jets are calming. Internal stress may be leveling off. If the peaks keep drifting, even slightly, then the forces twisting this object are still active. And if 3Y Atlas eventually breaks apart farther out, scientists will come back to this exact week and ask, did we see the warning signs? But rotation and brightness weren't the only red flags, because surrounding 3I Atlas was something even harder to explain. Something that didn't look like debris at all. Dust should be simple. Small grains get pushed away by sunlight. Big grains lag behind. Tail forms. Trail follows the orbit. 3I Atlas didn't cooperate. Images revealed a structure pointing roughly toward the sun and apparent anti-tail. Normally, that's just perspective trickery. This time, the math said, when researchers modeled the dust, they found the grains were huge, around 10 microns across. Massive by interstellar standards, big enough to resist radiation pressure. Big enough to hold formation, but still somehow lifted off the surface. That requires a very specific, very narrow set of conditions. Then came the optical depth calculation. The dust veil wasn't thin. It wasn't opaque. It sat almost perfectly at an optical depth of 1. That's the sweet spot where light is scattered efficiently. Details are hidden without total blackout. In other words, a shield. You can call that an absurd natural coincidence, or you can admit why some scientists quietly got nervous. Regardless of interpretation, the consequences are real. That dust structure is evolving right now. Stretching, twisting, becoming part of the solar system's debris environment. That's why deep exposures are still being stacked this week. Is the sunward feature still intact? Is it thinning or thickening? Is the debris trail forming in a way that Earth might eventually cross? This is the only chance to find out. But dust wasn't the only thing pushing 3A Atlas off expectations. Something else was quietly rewriting its path through space. On paper, 3A Atlas should have followed a clean hyperbolic trajectory. In reality, it didn't. From early observations, astronomers had to add non-gravitational forces to make the orbit fit. Jets were acting like thrusters, nudging the object off a purely gravitational path. And those nudges didn't stop. Even now, astrometric teams are still measuring its exact position down to tiny fractions of an arcsecond, feeding data into orbit solvers. If the extra push decreases, it means activity is fading. If it stays the same, or grows, it means 3A Atlas is still self-steering. That distinction matters more than most people realize. Sustained outbound thrust doesn't fit standard Comet behavior. It implies deeper internal activity, or something more exotic. At the same time, radio telescopes have been listening. So far, silence. But silence isn't closure, it's constraint. Every quiet hour lowers the ceiling on what could be happening. If something changes, a failure, a burst, a final signal, you only catch it if you're still listening. And then there's the bigger picture. Because 3I Atlas isn't alone. Rehook. When scientists lined up 3A Atlas with the other interstellar visitors we've seen, they realized this wasn't an anomaly, it was a pattern. We've now seen 3 interstellar visitors, and none of them behaved normally. Oumuamua accelerated without gas. Borisov looked familiar but chemically foreign. 3I Atlas combined extreme activity, structured dust, rotation stress, and self-steering. One anomaly is noise. 3 is a signal. That's why this week matters. Not because 3 Atlas might explode, not because aliens are confirmed, but because this object is training us. Every late data point becomes a rehearsal. Every anomaly sharpens our response for the next one. Someday another interstellar object will arrive with enough warning that we can intercept it. When that happens, what we choose to measure and how fast we act will be shaped by what we learned here. That's why scientists are still watching 3I Atlas this week. They're not watching an ending, they're writing a playbook. And until this object finally disappears into the noise, it still has one last job: to tell us what interstellar space is really sending our way. And our job? To keep watching.